So this is the called the Rapid Bioassessment Protocol. It was developed by EPA. And at first, it's not going to seem rapid at all. But once you get the hang of it, it will be. There are different data sheets for low gradient versus high gradient. The questions, some of the questions are very similar and some are a little different. I think everybody on the call tonight is working in high gradient streams. We want you to walk the whole 100 meters first and then fill in the sheet. This way, you're keeping the whole 100 meters in mind. Otherwise, you might have a tendency to look at just the section that's right in front of you, and that won't be representative of the whole 100 meters. So this is what the sheets look like all together, and then I'll go through each question close. Again, to review, I just said high gradient streams have some elevation above sea level, and this includes the highlands and the Piedmont region of the state. And the low gradient streams include the coastal plain region and the pinelands. Here's some photos that illustrate what a high gradient stream might look like. Sometimes we call them rocky bottoms because they usually do have a rocky bottom. And I'm not going to read through all these questions, but these are the 10 questions that are being answered for the high gradient rapid bioassessment protocol. And just real quickly, so you know what this is in contrast to the muddy bottom or low gradient. They're not always muddy, sometimes they're sandy, but they're usually not very rocky at all because we're talking about the coastal plain. They're going to look more like this. They're not going to have those boulders sticking out like you would probably see in a high gradient stream. And there are 10 questions. Most of them are the same, but there's a few that are different from high gradient. So the first question on the data sheet is asking about epifaunal substrate or available cover. It refers to the stable habitat that's present in the stream where macroinvertebrates can live, such as rocks, sticks, roots, and organic matter. So it's important to read the actual words of the question because that will help you decide on what number to choose. Each question is worth between 0 and 20 points, 0 being the worst stream, and up to 20 being perfect. So we don't very often give a 20, but it's just for one question. So it is possible sometimes to be giving a 20. I usually start with the condition category that I think is probably applicable to that stream. So let's just give it the benefit of the doubt and start out with reading the optimal description. So it's saying that 70% of the substrate is favorable for epifaunal colonization, including submerged logs, undercut banks, cobble, and other stable habitat. We're not talking about woody debris that's just floating past, because that doesn't have a chance for macroinvertebrates to live on it. Okay, I'm not going to go into detail on the low gradient, but so for suboptimal, that mix of stable habitats would only be 40 to 70%. In marginal would be 20 to 40%, and in poor would be less than 20%. So unstable habitat would be things like just like mud or silt. So question 2 is embeddedness. This talks about the degree to which fine sediments surround the coarse substrates. So how those cobbles and boulders are embedded into the stream. Aaron likes to say like it's peanut butter around them. Um, like how hard it is to pick up that rock. Are you disturbing a lot of sediment as you're picking it up? If it's an optimal stream, those rocks are only going to be surrounded by 0 to 25% of fine sediment. So it's going to have lots of places for macroinvertebrates to live. There's little nooks and crannies for them to live. And if there's less, 25 to 50%, it would be in suboptimal range. Marginal would be 50 to 75% covered by fine sediment. And if it's more than 75%, that would be poor. Here's an illustration of what that might look like. So if it's 0 to 25%, you're seeing like the rocks and cobbles. As you get more, you can see that there's just like silt in between instead of being able to see the outlines of the rocks. I'm going to skip over the low gradient section. So the next question asks about velocity and depth regimes. So there are 4 choices of velocity depth regimes. There's slow deep, slow shallow, fast deep, and fast shallow. So you can understand why it was important to look at the whole 100-meter stretch, because each one of these might be in different locations of the stream. You might not be able to tell how deep a spot is or shallow until you actually walk in it. So slow is less than 0.3 meters per second. I know that's hard to visualize, but basically it's not disturbed on the top. It's moving the water is moving very slowly. Deep is not particularly deep. It's over half a meter. So it's more like knee deep. So it doesn't have to be very deep, but if you're a small macroinvertebrate, that seems deep. If you have all that diversity, if you have all 4 of those, then you would be up in the optimal section. But if you only have 3 of the 4, you would be down in the suboptimal. And if the fast shallow is missing, you would score it with a lower score, maybe the 11 or 12. But if you do have fast shallow and something else is missing, then you could give it a better score, like 14 or 15. If you only have 2 of the 4 habitat regimes present, then you would be down in the marginal section. But if you only had 1 type of habitat, you'd be in the poor section. For sediment deposition for the next question, in the optimal situation, there's little or no enlargement of islands or point bars, and less than 5% of the bottom is affected by sediment deposition. It's the amount of fine materials that are present and the presence of sandbars. So this is always a little bit of, awkward to answer, because you're like, well, I've never been here before. I don't know if this is a new sandbar. I don't know if there's more gravel deposited here than there was before. But basically, you will be able to tell if there is a sandbar and if there's gravel deposition. And if that is more than 5%, then you would not be in the optimal range. If it's between 5 and 30%, you would be in the suboptimal range. If you have 30 to 50% is deposition, then you would be in marginal, and greater than 50%, you would be in the poor range of the condition. So I hope that this photo gives you a little better idea. The words don't always convey the idea of what this would look like. So you can see, especially in the bottom left and sort of in the middle left, there's a lot of gravel and sediment where the water probably used to be. And there's just been this deposition from upstream erosion that is impeding the flow of the stream. And so this one would, depending on how extensive this is, as a portion of your 100 meters is how you would score it, but it definitely would not be in the optimal range. Here's another example. This is like a point bar where there's sediments and even like larger rocks that got eroded from upstream, and they're depositing in the middle. The next question is called channel flow status. It refers to the amount of water filling the channel. So in an optimal situation, the water reaches the base of both of the lower banks and a minimal amount of the channel substrate is exposed. So this is a little bit similar to the previous one, where if there's a lot of gravel exposed on the sides, it's not going to be in the optimal category. If the water fills 75%, then you're in the suboptimal category. If the water only fills 25 to 75%, you're in marginal. If there's very little water in the channel, mostly as standing pools, you'd be in the poor situation. So you can see how this, the answer to this question is going to depend a lot on exactly when you're visiting the stream. If it is a drought year and you're doing your assessment in the middle of the summer and the middle of the drought, you're going to be giving this stream a lower score than if you had visited it in the spring. And that's normal, that happens. The condition is going to vary throughout the year. And this photo illustrates what that would look like. So the width of the stream where the water normally would be is the yellow line. So you can see where the kind of where the roots go down. You can see that at some times of the year that's where the water is. But in the time that this photo was taken, the water is only where the red line is. So you can see that it's maybe only 50% at this location. The next question is about channel alteration. It asks, has the path of the stream bed been altered in any way, and was it recent? This is, maybe an awkward question again to answer because you don't know, you weren't there when it happened. Maybe it was a long time ago. But if you can't see evidence of channelization or dredging, and if the stream has a normal pattern, and again, what's normal? Well, if it's very, very straight, then that's not terribly normal. So most streams are going to naturally have at least a little bit of a curve to them. So if you don't see anything and the stream looks pretty normal in its channel, then you could be in the optimal situation. But if there's some channelization present, but maybe it happened a while ago, you could be in the suboptimal category. This could be something like you can see that some rocks were placed on the stream bank to stabilize it. So you can tell that people put that there, but otherwise it looks fairly natural. Maybe you're in this suboptimal category. If the channelization is extensive, and remember you're looking at your 100 meters, you can see it's shored up with different structures that maybe affect 40 to 80% of the stream reach. And maybe it's very straight, then you would be in the marginal category. If the banks are shored with gabion or cement for over 80% of the stream reach, and it's greatly altered, then you're in the poor category. Here's an example of a channel that is highly altered and would definitely be in the poor category. I wouldn't even recommend doing a stream assessment here. For one thing, there's fences that prevent you from getting into that water. And for another thing, there's no natural habitats for macroinvertebrates to live in, but it's just showing this slide so you can see the extreme alteration. In this picture, on the left, it's very altered, but on the right, it looks natural. So you would be, somewhere in the middle, especially depending on how much is the entire left side of the bank, like what you see in the front here, or maybe it's just maybe 25% of it or something like that. So you would take that into account when you choose a number. Here's a location where you can see that those rocks were put there by people. They look stacked. They look like they were put there to reduce erosion, but they're kind of blending in. So you wouldn't give it a perfect score, but you wouldn't rate it as low as the previous two slides. And the side that's closest to us, that looks like it's pretty natural. The next question is called frequency of riffles. So riffles have the benefit of adding oxygen to the water. So that's really great for aquatic life to have lots of oxygen in the water. And so we want to know how many riffles there are based on the width of the stream. If it's optimal, the occurrence of riffles is relatively frequent, with a ratio of the distance between riffles divided by width of the stream is greater than 7:1. And I know it says less than, but I think that we need to fix that. So if it's completely riffles, that's great. But you also want to see that there is some variety. So you want to see some boulders that are sticking out and other places that are a little different, so that there's a variety of habitats available. I know it gets a little that description is kind of wonky, asking you to do all this math or anything, but so I provided an example at the bottom. If the stream is 10 meters wide, the optimal would have a distance between riffles of 50 to 70 meters. So you're going to want to see at least two riffles within that stream length. But if you are seeing only one riffle, maybe the next riffle is, you can see it in the distance, maybe it's 150 meters between, then you would be in the suboptimal category. If you could only see riffles every 150 to 250 meters, that would be marginal. And then poor would be if there's even less than that, maybe no riffles at all. This one's for low gradient. Okay, so bank stability is scored separately for left bank and right bank. So the total for this question is going to be between 0 and 20, just like the other questions, but you're going to look at each bank separately and give a score between 0 and 10 for each bank. So bank stability refers to the severity of erosion occurring on the banks of a stream. So you're not looking very far from the water. You're just looking at the stream banks, maybe a few meters. And if it's optimal, the banks are going to look stable. Evidence of erosion or bank failure is absent or minimal, and there's little potential for future problems, with less than 5% of the bank affected. And as you go to suboptimal, there's maybe some erosion, 5 to 30% of the bank is affected by erosion. If you're in the marginal category, between 30 and 60% of the bank has erosion, especially during floods. And if it's poor, it's unstable with many eroded areas raw, or like you can see the dirt, you can see where the erosion has happened. Maybe it's very recent. You might see sloughing. I have a picture of that to describe what that looks like. And affecting between 60 and 100% of the bank. So in this picture, we're looking at the two separate banks, and they both look very well covered by vegetation, and I'm not seeing any erosion. So I would score this section extremely well. This one, I'm seeing a little bit more erosion down towards the water. This one, I'm seeing some very severe erosion. Those roots, those tree roots, used to be in the ground, but that ground has now been eroded away, and there's bare ground there. So this one I would score, much lower. And here's some sloughing. Sloughing means like that water, that the stream bank has been so eroded by the water that it's just falling down into the stream. It's sloughing into the stream. So that's what that would look like. And with the extreme storms that we've had in recent years, I unfortunately see this pretty commonly. Another illustration of that, you can see those tree roots hanging down there. Looks like the trees are about to fall in. Looks like the ground is about to slough off down into the stream. So I would score this one, much lower. Okay, we're up to our last question. This one also gets scored separately for each bank, and it's asking for you to describe the bank vegetative protection. So how much of the stream bank is in the immediate riparian zone is covered in vegetation? If more than 90% of the stream bank is covered with native vegetation, sorry, second to last question. I got ahead of myself for a moment. Start over with that. 90% of the stream bank is covered by native vegetation, including trees, understory shrubs, and non-woody plants. If there's no vegetation through disruption through grazing or mowing, and the plants are allowed to grow naturally, that would be in the optimal section. If only 70 to 90% of the stream bank is covered by native vegetation, and one of those types of plants is not well represented. So maybe there's trees, but there's no shrubs because maybe there's deer that have eaten all those shrubs, or maybe the erosion, is not letting plants grow properly, or maybe there's some mowing of grass. Then that would, be preventing the plants from growing to their natural form. So if it's 70 to 90% of the stream bank, then it would be in suboptimal. If there's 50 to 70% covered by vegetation, maybe you see patches of bare soil, and maybe mowing or grazing, then you're in the marginal category. And if less than 50% of the stream bank is covered by vegetation, there's a lot of disruption to the stream bank, then you're in the poor category. And you'll notice in this section that it also talks about native vegetation, and not everybody knows their plant identification, and that's fine. If you do know your plant identification and you observe that there's a lot of invasive species, you can subtract 1 point for each bank. So if you had on the previous slide, if you had picked that you'd picked a number for how well the stream banks are covered by vegetation, but then you notice that some of those plants or a lot of those plants are invasive species, then you would subtract. So say you had decided that you wanted to give it a number 8, but there were a lot of invasive species, then instead you would give it a 7. You just subtract that 1 point. That way we're kind of consistent. We're doing our scoring consistently. This slide shows, very well represented between trees, shrubs, and non-woody plants. They're not being grazed or cut down. So this would score very well. And both sides look good. And this one looks like a lot of the understory looks like it might be multiflora rose or something. So that would reduce the score by a point. Now, this is the last question this time. Riparian vegetation zone width. So how extensive is the vegetation on both sides of the stream? The choice for the optimal would be a riparian zone width of greater than 18 meters, where human activities have not impacted the zone. So 18 meters is only 60 feet, so you're not looking very far. Examples of human activities are parking lots, roads, lawns, a fence for animals. Is there a path? And a path, depending on how impactful you think that path might be, you could give it, you could not penalize the stream for having a path next to it if you don't think it's impacting the stream at all. But sometimes you can tell there's a lot of foot traffic, maybe animals, like dogs going to the bathroom or something, then you might take off a little bit for that. So for example, if the width of the riparian zone is 12 to 18 meters and human activities have impacted the zone, but only minimally, then you would be in that suboptimal category. If the width of the riparian zone is 6 to 12 meters and human activities have impacted the zone a great deal, you'd be in marginal. And if the width of the riparian zone is less than 6 meters with a lot of impacts from human activities, you'd be in the poor category. So in the foreground here, we don't see any natural riparian vegetative zone. We're just seeing grass mowed down to the stream. So this one would be in the poor category, unless your stream width included part of that wooded section in the distance. And then you would take that into account. In this picture, there's a park and mowed grass on the left. On the right, there's a little more of a riparian vegetation width, but just past that, there's like a fence and a field. It might be hard to see in the photo, but so it's not ideal, but you would score the right side better than the left side. When you're done with giving all those numbers, and I forgot to say, like, you can talk over your reasoning for choosing a number with your partner or partners. This helps you, come to an agreement on the number to choose. And at the end, you add that up. And what your total is means that the habitat for that section is either optimal, suboptimal, marginal, or poor. And don't go back and change your answer. It's just like, oh, if I'd only given it one more point, it would have been optimal. You get what you get at the end. Really, it's and surprisingly, it comes out, or I felt a little surprised when I saw how consistent people could be with what habitat score they ended up with. They would, it feels like it's very subjective while you're doing it, but in the end, after you've done it a few times, you can be pretty consistent with other people doing the same method. So a few things to remember. Consider the whole 100 meters when you're answering each question. Assess the habitat after your macroinvertebrate collection. This is really helpful because as you're collecting your macroinvertebrates, you're walking the whole length, and you're very much looking at the substrate, the stream banks, the vegetation. You're getting you're taking in a lot of information. that will be helpful when you're going to answer the questions. Do your habitat assessment together and bounce your ideas off one another. So I don't recommend that like one person do the macro collection and one person do the habitat, because it's really a teamwork kind of a situation. You'll get to a better result if you do it together. But don't stress too much. Like I said, really does come out pretty well once you have a little bit of experience with it. It's gonna work out. You're gonna come up with an agreement with a good score that's representative of your stretch.